Hello students, in last lecture we had discussed about first come first serve CPU scheduling algorithm. Now what is first come first serve? The process which arrives first will be executed first. And for that we have made Gantt chart and designed what are information which we should know before solving the question and what is outcome which was demanded. So we require process. What else we require? Apart from process, we require bus time and arrival time, and we need to design the chart. So once we have all those stuff, what we want to generate, that is turnaround time and waiting time. So these are the things which we require. Now today what we'll do, we'll discuss next algorithm. Since we had completed this one, we will discuss shortest job first. Now why we have moved to the shortest job? Well, let's start with this particular thing and then we will pick that how shortest job first algorithm works. So we had picked that first come first serve have one advantage, that it is quite easy to implement, but it have one disadvantage, that if any longer process which want to execute for more burst time, which we had picked, suppose that is P0, P1 and P2, suppose there are three processes, burst time is given 100, 50 and 5, and suppose all are arriving at the 0th time, means all arrived at the same time. But if I want to execute with respect to first come first serve, my chart will be that from 0 we process the process which is given in order. uh, First one will get executed first, so first of all P0 will get executed up to 100, then P1 will get up to 150, and then finally P3 will get chance up to 155. Now what will be the waiting time? For P0 process, the waiting time will be 0, since it arrived at 0 and immediately got chance for execution. What will be for P1? P1 arrived at 0 and got chance for up to 100. So 100 minus 0, that is 100. So P1 waited for 100 unit of time. And P3 waited for 150 unit of time. So total waiting time becomes 250 unit of time. That is in FCFS. So logically, if we think about this thing, that if few processes which are arriving at the same time and they formed certain order. Now, if you have processes for comparative analysis, so let's opt for the smallest process for execution so that no other process should wait for longer time. This is in a similar manner that suppose 5 person has came to the shopping mall. So the person or manager of shopping mall will ask to the all five that how much amount of time they want to invest or they want to spend in this shopping mall. Now, the person who will invest the minimum amount of time will be preferred first, so that each and every one have to wait very less amount of time. So that is the overall concept behind the shortest job first. Now, let's try to prove it that how shortest job first is better one, especially in these kind of scenario. So I am going to design for SJF. So again, I am going to start with 0 because my arrival time is 0. Now which process I should pick first? So my system says since all three processes P0, P1 and P2 arrived at the same time. So the smallest process in terms of burst time is P2. So I'll execute P2 for full unit of time, that is 5. Now after completion of P2, what I'll do, I'll execute P1. So it will get started from 5 and will run up to 55. After completion of P1, now I'll move for the P0 and it will run for 100 unit of time. So 155. Now here you can see 155, 155. So ending time remains same. Reason start and starting time is also same. Hence the total bus time is what we are going to execute. And total bus time says that it is 155. So this is the time which we will get here. And that is also one trick also, that if you want to check that whether you have designed your chart in a proper manner or not, so your total time of chart is equal to last time minus first time. Now why I am saying last time minus first time? Because it's not necessary that always you are going to start with 0. There will be certain problems where you will start with 5. Hence, last time minus first time, that will be the total time for the chart. Now, this will be equivalent to total burst time always, except one condition. That condition is that if I have certain idle portion in mid. So except this particular thing, my total burst time will be equivalent to the total time of chart given here. So whenever you make your chart, add your burst time here and check that is your total time, which is last time minus first time, is equivalent to your burst time. If it is not equal, it means somewhere you have done mistake. We cannot say that where you have done mistake, but yes, you will identify that I have done mistake, and now you can immediately move for the rectification. So let's come to again our topic, that is shortest job first. Now let's try to pick waiting time of SJF, that is for FCFS. Now SJF waiting time. You can write in any order. It's totally depends upon you. There is no restriction that you need to fill the entries in top to bottom manner or bottom to top manner. So I'm going to pick from here P2 reason. P2 got started, so it started 0. So waiting time is 0. Now P1. P1 arrived at 0 and got chance for 5. So waiting time is 5. Now P0 arrived at 0, got chance at 55. So waiting time is 55. So what is total time? Total time is 60. It means in shortest job first, you have reduced time almost up to 1/4 of the waiting time with respect to FCFS, or even more than 1/4. So that is the major advantage of shortest job first algorithm. I hope that it is clear that what was the disadvantage of FCFS, and we have taken that disadvantage and designed one algorithm on the basis of that disadvantage and created a new algorithm which is performing better than the previous one. So that is shortest job first. Now, shortest job first have two different variations, or I can say that there are, with respect to execution, process have two variations. One is preemptive and the other one is non-preemptive. Now, what is preemptive and what is non-preemptive? So we will discuss this preemptive and non-preemptive aspect in our next class, and then we will see that how SJF perform with respect to preemption, with respect to non-preemption. So that we will do in our next class.